All right, guys, on to 3-4 today. 3-4 is about dilations. And so this is our only transformation that is not rigid, meaning, oh, sorry, I almost lost the computer, meaning that the shape of it or the size of it will change, okay? And so we actually only have this one page to work on today. I would recommend that you have at least 4 different colors that you can take these notes with. If not, if you don't have 4 different colors, just make sure that you label your notes very, very carefully, okay? So our objective today is to just dilate a figure from the origin by a certain scale factor. And so our only new vocabulary today is dilation. So let's go ahead and go to the end of our packet, define it, and then we can come back and do some practice. Okay, so here we have our definition of dilation. It's a type of transformation where the shape is still the same, but the size is not. Okay, so the shape but not the size is preserved. I also want to make a note here that the angles also stay the same. The same. Okay, so your angles are also staying the same. So like if I have, let's say, a little cute little trapezoid here, right, and I dilate it, it can become bigger trapezoids. Think of like when you go to the eye doctor or something like that, right? And they say, oh, your eyes are dilated or your pupils are dilated, right? It means your pupils have gotten bigger. And dilation, you can also get smaller as well. You can get bigger or smaller. But that's just an example of like a real world situation where we use that word dilation. And so dilations aren't super hard. All we do here is we multiply each coordinate. And remember that the coordinate in our figure is just that XY point, right? Each corner or whatever it is by the scale factor. So whatever the scale factor is, that's what we multiply it by. And more specifically, this is just when we have dilations from the origin, which is all we're going to look at for right now. Okay, so you would just multiply the coordinates by the scale factor and then connect the dots and have the shape. So let's go back to 3-4 and take a look at this and see if we can do some practice. Okay, so we're going to start here with part A. Part A says to dilate the quadrilateral ABCD by from the origin. So it's important that they're all from the origin, right? By a scale factor of 2. So first thing I'm going to do is I'm going to find all the points of my original quadrilateral, which is just a 4-sided shape. So I have point A is at 3, 2. Point B is at -1, 2. Point C is at -2, -2. And point D is at 1, -2. Okay. And so here I have a scale factor of 2. So all I'm going to do is I'm going to multiply. Let's see if I can write this off to the side. Multiply A, B, C, D by 2. So I'm going to multiply A by 2. 3 times 2 is 6. Right? 2 times 2 is 4. So A prime is at the point 6, 4. Draw it real small. A prime. There we go. B prime is at the point -1, 2. So -1 times 2 is -2. And then 2 times 2 is 4. So B prime is at negative 2. 1, 2, 3, 4. Did I count that wrong? Oh no, I counted this one wrong. Sorry. There's A prime. It's so tiny, I have a hard time seeing it. Okay, negative 2, 1, 2, 3, 4. And that is B prime. Okay, C prime. If I multiply by 2, I get negative 4, negative 4. So negative 4, 1, 2, 3, 4. So there's C prime. And then D prime, if I multiply by 2, I get 2, negative 4. 1, 2, 1, 2, 3, 4. And there's D prime. And then all I'm going to do is very, very, very carefully connect. If we were doing this in class, I would have a ruler. We want this to be pretty perfect. And there is my dilated figure, right? A prime, B prime, C prime. Okay, so what I want you guys to do is for A, B, C, and D, I want you to use a different color as you go, just so that you can distinguish. And I want you to try. I want you to dilate A, B, C, D by a scale factor of 3. Then I want you to dilate it by a scale factor of 4. And then I want you to dilate it by a scale factor of 5. Okay, and it with each color. And then make sure, like, so for me, I'm going to use green, right? So for B, they're going to be A double prime. For C, I'm going to use like a triple prime. So 3 of them, which is allowed. That's okay. And then for D, I'm going to use a quad prime. So 4. Just so you know, just so we're aware of what's happening, okay? And then this was A prime. So I want you to try A, B, C, and D. And then when you are ready to check your work, come on back and I'll have it up for you. Okay, so here we have all of the work from A, B, C, and D. D didn't quite fit on the page, so I did it over here on the left. Okay, so I want you to make sure you check your work. If you have to pause the video to check your work or whatnot. Again, normally I would have done this with a ruler, so it would be nice and pretty, but I did the best I could, okay? The last part is question E that says, how are the quadrilaterals you drew related to each other? So looking at these three, or sorry, there's 5 of them, right? So we can say they are similar. And so what similar means, if we remember, is that they're the same shape. And if they're the same shape, that means that the angles are the same too. The same shape, which means same angles. Oops. But different sizes. My pen is real not happy with me today. Different sizes. Same shape, same angles, but different sizes. So what we mean by that, right, is the same shape, it's just getting bigger and bigger and bigger, or smaller, smaller, smaller. So that's just a quick overview of dilations. All you're doing is just multiplying the coordinates by whatever your scale factor is. The last lesson that we have in this topic, in this unit, is all about symmetry, and so that's going to be our next video, and we'll see you then.